Hello, another pizza is here. I hope you have been enjoying our previous pizzas, and I know you also enjoy today's pizza. Today on physics meal and also physics pizza, we are going to solve a question from wave. Let's go together. A note of frequency 2000 Hz has a velocity of 400 meters per second. Calculate the wavelength of the note. We got this question from WAEC 2006. The objective. It's an objective question number 29. So let's go together. So a note of frequency. The symbol of frequency is F. That's what we use in physics. 2000 Hz, we have been given the frequency. Has a velocity of 400 meters per second. So the velocity V is 400 meters per second. They say calculate the wavelength of the note. The wavelength of the note. That's lambda. Lambda. That's what we are looking for. Lambda. Don't mind me. It's not our alphabet anyway. It's the Greek. It's a Greek letter, so we call it lambda. You know, if you are conversant with wave. All right. So let's go together. What expression, what formula are we going to use to solve this? What's the relationship between velocity, frequency, and the wavelength? The relationship is V is equal to what? Lambda F. So I'm looking for this guy, lambda. So we know V and we know this. So V is 400. If I substitute lambda times the frequency is what? 2000. So I have 400 is equal to 2000 lambda. That's what I have. So dividing both sides by what? By 2000, we have 400 over 2000 is equal to 2000 lambda over 2000. So this is gone. I'm left with lambda. So when this is gone with this, we'll be having around 0.2. So lambda becomes 0.2 meters. That's what we're going to have, because 400 divided itself is 1. 400 divided 2000 is actually 5. And when 5 divide 1, we have 0.2. The unit of lambda is meters. That's why we have to attach that unit to the value that we just obtained. All right. Thank you for following us on today's physics meal and also physics pizza. Till we come your way again, continue to enjoy our meal, especially the pizza aspect of the meal. Thank you and God bless you.